Hello everyone. Today we will see some foundation questions or some practice questions from the chapter Thermochemistry. So this is part 1. So let's start. First disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index slides and today we will going to see some practice questions from question number 1st to question number 14. So let's start with the question number 1st. Del H naught F of NO2 yani standard enthalpy of formation of NO2 is 33.84 kilojoule per mole and standard enthalpy of formation of N2O4 is 9.66 kilojoule per mole. Hence, dimerization of NO2 forming N2O4 is. Options are endothermic, isothermic, exothermic or isochoric. So you have to tell the type of reaction which will be going to happen when we do the dimerization of NO2 forming N2O4. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so we have answer option number C. So this is the reaction followed when we do the dimerization of NO2 to form the N2O4. So two molecules of NO2 will form N2O4. So del H naught will be equal to enthalpy of formation of N2O4, that is product, minus 2 times enthalpy of formation of NO2, that is reactant. And on putting the values given in the question, we have the del H naught for reaction will be minus 58.02 kilojoule per mole. And since we observe that the del H for the reaction is coming out as negative, thus reaction is exothermic. Okay, hence option C will be the correct answer. Let's move to question number 2. In the reaction Y to Z, del H is plus 100 kilocalorie per mole, and for the reaction Z to X, del H equals to minus 80 kilocalorie per mole, and Y to X will be del H equals to 20 kilocalorie per mole. Rank the enthalpies of formation of X, Y and Z in increasing order. So we have options here: YXZ, YZX, XZY or XYZ. So you have to tell the enthalpies of XYZ in increasing order, and we have given the del H for every reaction. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. So we know that del H enthalpy change of reaction is equals to summation of enthalpy change of formation for the products minus summation of enthalpy change of formation of reactants. So in the equation this one Y to Z, we can write that standard enthalpy of formation of Z, that is product, minus standard enthalpy of formation of Y equals to 100 kilocalorie per mole, which is given. That is, we can see that the total enthalpy of reaction is coming out as positive. That means in this equation, del H naught formation for Z is greater than del H naught formation for Y, right? Similarly, we observe in this process that del H naught F for X minus del H naught for F of Z equals to given as minus 80 kilocalorie per mole. And we can see that the total enthalpy change for the reaction is coming out as negative. That means in this equation, this is greater than this. So we can say that del H naught formation for Z is greater than del H naught formation for X. right? And similarly, we observe these things in this reaction also, that in Y to X, del H is given as plus 20 kilocalories. So when we write the enthalpy change reaction, we can clearly see that it will be for product minus reactants and coming out as positive. So del H formation for X will be greater than del H formation for Y. So you can observe that Fx, that enthalpy change for X is greater than enthalpy change for Y, and enthalpy change for Z is greater than enthalpy change for X, right? So on combining these two things, we can say that overall order is that the enthalpies of formation for Z is most, then enthalpy of formation of X will come, and the enthalpy of formation of Y is least. So this is the overall order of enthalpy of formations of X, Y and Z, right? Hence option A is the correct answer. Okay, let's move to the question number 3rd. 2.1 gram of iron combines with sulfur, evolving 3.77 kilojoule. The heat of formation of ferrous sulfur or ferrous sulfide in kilojoule per mole is. So options are minus 1.79, minus 100.5, minus 3.77, or none of these. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be B option, that is minus 100.5. So let's see how. When 2.1 gram of iron combines with sulfur, the heat evolved is 3.77 kilojoule. This condition is given in the question. So when 1 mole, or you can say 56 gram, which is the atomic mass of iron. So when 56 gram of iron combines with sulfur, then the heat evolved will be, so we are calculating the heat evolved per mole of FeS is 3.77 multiplied by the atomic mass divided by the 2.1 gram. It is coming out as 100.5. So since the heat is evolved in the formation of FeS, the heat of formation of FeS is minus of 100.5 kilojoule per mole. Minus sign is because heat is evolving in the formation of FeS. Okay, so that's why option B will be the correct answer. Okay, so let's move to question number 4th. Which of the following is or are exothermic reactions? First, combustion of methane. Second, decomposition of water. Third, dehydrogenation of ethane to ethylene. And fourth, conversion of graphite to diamond. Options are first and second, second and third, third and fourth, or second, third and fourth. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option D. So second, third and fourth. So for the combustion of methyl, this reaction will be happening. So here we have methane. The combustion will happen, that is reaction with O2 oxygen. It will produce 2CO2 plus H2. Decomposition of water. So H2 in liquid form will give you H2 gas plus half of O2 gas plus heat will be evolved. Dehydrogenation of ethane to ethylene. So here we have ethane going to CH2 double bond CH2, that is ethylene and H2 molecule, and heat is evolving in this process. And conversion of graphite to diamond. So C, that is carbon in graphite state, in solid state, combining with oxygen molecule, giving you carbon monoxide and evolving heat. So you can observe that in decomposition of water and dehydrogenation of ethane to ethylene and in conversion of graphite to diamond, we have exothermic reactions because they proceeds by the evolution of heat. In 3 of them, the heat is evolving. That's why they all have exothermic reactions. Okay, so that's why option D will be the correct answer. Let's move to question number 5. The delta H naught formation for CO2, CO and H2, that is carbon dioxide, carbon monoxide and water, are this, and this kilojoule per mole respectively. The standard enthalpy change in kilojoule per mole for the reaction this is. So reaction is CO2 plus H2 will give CO plus H2. Options are 524.1, 41.2, minus 262.5, minus 41.2. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be B option, that is 41.2. So let's see. So we have delta H, that is standard enthalpy of formation for CO2, CO and H2 in the question given. So we write the reaction for that. So for the formation of CO2, we add carbon plus O2 will give you CO2. This reaction for enthalpy of formation is this. And for the CO, C plus half of O2 will give you CO, carbon monoxide. This reaction has standard enthalpy of formation this. And for the formation of H2, H2 plus half of O2 will give you H2O. So standard enthalpy of formation for this is this. And we are considering these equations first, second and third. So we add the second and the third equation and then we subtract the resulting equation in from the resulting equation to the equation first. So the reaction which is finally coming out is CO2 plus H2 will give you carbon monoxide plus H2, which is given in the question. So for this reaction, the enthalpy change will be equal to enthalpy formation for product minus enthalpy formation for reactant. So enthalpy formation for CO plus enthalpy formation of H2O minus enthalpy formation for CO2. This will be equal to putting the values which is given already in the question, and it is after subtracting and adding, it is coming out as 41.2 kilojoule. Hence option B is the correct answer. Let's move to question number 6. Consider the following. So here one reaction is given, here one reaction is given having enthalpy of X and having enthalpy of Y. So carbon plus oxygen will give you carbon dioxide, enthalpy is X. Carbon monoxide plus half molecule of O2 will give you CO2. This will give you CO2 and the enthalpy is Y. So then the heat of formation of carbon monoxide we have to find. So options are X minus Y, Y minus 2X, X plus Y or 2X minus Y. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A, that is X minus Y. So let's see how we have given this equation in the question. C plus O2 will give you CO2, del H for this is X. And we have this equation also in the question, that is CO plus half of O2 will give you CO2 and del H for this is Y. On combining these two equations or rearranging these two equations for getting the heat of formation of CO, that is CO should be in the product side. So we have to make sure that this CO present in this reaction, in this second reaction, should come at product side. So we have to reverse this reaction, and if we reverse this reaction, its enthalpy change will also get reversed, so Y will become minus Y, and hence then after adding these two conditions, carbon plus O2 and then half of O2 remaining will be half of O2, and on this side only CO will remain to CO. So this is the reaction for the formation of carbon monoxide, and the enthalpy or heat of formation for the carbon monoxide is coming out as X minus Y, because we just reversing this reaction, so it becomes minus y, and then we are adding these two equations, so it becomes x plus of minus y, that is x of minus y. Hence option A is correct answer. Okay, let's move to question number 7th. On the basis of following thermochemical data, delta H naught for formation of H positive in aqueous solution is equals to 0. It is given. So we have two equations. We have the ionization of H2 in liquid state, and we have the formation of H2 in liquid state, and we have their enthalpies here. And also the standard enthalpy of formation for H positive is 0, which is given here already also, right? So the value of enthalpy of formation of OH minus ion we have to find out at 25 degrees Celsius. So options are minus 22.88 kilojoule, minus 228.88 kilojoule, 228.88 kilojoule, or minus 343.52 kilojoule. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So consider the equation in the formation of H2. So H2 plus half of O2 will give you H2, and the delta H or change in enthalpy is given for this reaction is this in the question. That is delta H formation for H2 in liquid state is this, you can say, right? Because it is same, and we are forming H2 in liquid state. So now consider the ionization of H2, which is carrying out the according to the reaction given in the question also. H2 in liquid state will give H plus ions and OH minus ion in the aqueous solution, and del H for this reaction is 57.32 kilojoule, right? So if we write the enthalpy of reaction, it will be equal to enthalpy change of formation of product minus reactants, right? So enthalpy for heat of enthalpy of formation will of H positive, that is this product, plus heat or enthalpy of formation of OH minus reactant, that is enthalpy of formation of H2 in liquid state. On putting the values given in the question, del HR is 57.32, or del F of H plus is basically 0, and del H of OH minus we have to find out, and minus of del H of formation of H2 we have given minus 286.20, so it is coming in bracket. So minus minus will become plus, and on moving this in to the left side, we have the enthalpy of formation for OH minus ion is 57.32 minus 286.20, which is minus 228.88 kilojoule. We have taken this enthalpy of formation for H positive as 0 because it is given in the question here. Okay, hence option B will be the correct answer. Okay, so let's move to the next question. Question number 8. The heat of combustion of carbon and carbon monoxide are this and this respectively. The heat of formation in kilojoule of carbon monoxide per mole is. So we have to find out the heat of formation of carbon monoxide only. So options are 676.5, minus 676.5, minus 110.5, 110.5. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. So we have carbon dioxide combustion reaction. We have carbon combustion reaction, which is C plus O2 will give you CO2, and the del H is given in the question for this reaction is this. And carbon monoxide also undergoes the combustion reaction, and the enthalpy change for this reaction is given as this. On subtracting, this second equation from the first equation, we get carbon plus half of oxygen molecule is equals to CO, carbon monoxide molecule. So del H will be also like equation second enthalpy minus minus of equation first enthalpy, right? So it will become minus 393.5 minus plus of 283.5 kilojoule per mole inverse, and it is coming out as minus 110 kilojoule per mole, right? So that will be the answer, and the correct answer will be C. Okay, let's move to question number 9. If enthalpies of formation of C2H4, CO2 and H2O at 25 degrees Celsius and 1 atmosphere pressure be 52, minus 394 and minus 286 kilojoule per mole respectively, the enthalpy of combustion of C2H4 will be. So options are 1412 kilojoule per mole, minus 1412 kilojoule per mole, 141.2 kilojoule per mole, or minus 141.2 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be B option. So we have this equation, which is combustion of C2H4. So C2H4 plus 3O2 will give you 2CO2 plus 2H2. So del H for this reaction will be twice of enthalpy of formation for CO2 plus twice of enthalpy of formation for H2O minus enthalpy of formation of C2H4 plus 3 times enthalpy of formation of O2 molecule. And here in this equation, enthalpy of formation for oxygen will be 0 because oxygen is a diatomic molecule and it is stable at the standard conditions. So as we have given 25 degrees Celsius and 1 atmosphere pressure, it is standard conditions. So the enthalpy of formation of O2 will be 0. Now on putting the values in this equation and solving on it, we have our del H for the reaction is minus 1412 kilojoule per mole. Hence option B is the correct answer. Moving to question number 10. Heat of combustion of H2 is minus 241.8 kilojoule per mole. For carbon, it is minus 393.5 kilojoule per mole, and for ethanol, we have it is at as minus 1234.7 kilojoule per mole. Hence, heat of formation of ethanol in the liquid state is. So options are minus 2747.1 kilojoule per mole, minus 277.7 kilojoule per mole, 277.7 kilojoule per mole, or 2747.1 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B, and we have this equation here, which is H2 plus half of O2, that is combustion of H2, giving you the H2O molecule, and the heat of combustion for this reaction is given here in the question, and heat of formation for H2 you can say is equal to heat of combustion of H2, right? Because in this reaction H2 is forming, right? H2 is formed. So we can also say that heat of combustion of H2 is equals to heat of formation of H2. So these both are equals. Now second is combustion of carbon. So carbon plus O2 will give you CO2, and their heat of combustion is minus 393.5 kilojoule per mole. We can also say that this is same as the heat of formation, enthalpy of formation of CO2 molecule. And in the case of ethanol, we have the combustion of ethanol reaction here, and the enthalpy for the combustion is given as minus 1234.7 kilojoule per mole. So for this reaction we can write the enthalpy change equals to twice of enthalpy formation of CO2 plus thrice of enthalpy formation for H2O minus enthalpy formation for C2OH. This will enthalpy formation for O2 will be 0. So on putting the values in this equation, we have minus 1234.7 equals minus 2 times 393.5 minus 3 times 241.8 minus this value, which is we have to find out, that is enthalpy of formation for C2H5OH. So standard or heat of formation for ethanol is coming out as minus 277.7 kilojoule per mole. Hence option B will be the correct answer. Let's move to question number 11th. Combustion of glucose takes place according to the equation this: C6H12O6 plus 6O2. This will give you 6CO2 plus 6H2, and del H is minus 72 kilocalorie for this reaction. So how much energy will be required for the production of 1.6 gram of glucose? And we have given the molecular mass of glucose, which is equal to 180. So options are 0.064 kilocalorie, 0.064 kilocalorie, 6.4 kilocalorie, and 64 kilocalorie. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see the answer. Answer will be option B. So we have given the heat or enthalpy of combustion, which is minus 72 kilocalorie for this reaction here, and the heat of formation for glucose will also be 72 kilocalorie. We just reverse this reaction and it will become the formation of glucose reaction, right? So enthalpy will be enthalpy of formation for glucose, and the sign will also change on reversing the reaction from minus 72 to plus 72. So for 180 gram of glucose, del H will be 72 kilocalorie, right? Because 1 mole is forming from this reaction. So 1 mole is 180 gram. So 180 gram of glucose, for 180 gram of glucose, the enthalpy change is 72 kilocalorie. So for 1.6 gram of glucose, the enthalpy change will be 72 multiplied by 1.6 divided by the molecular mass 180. And it is coming out as 0.64 kilocalorie. So correct answer will be B option. Okay, so let's move to question number 12. The heat evolved in the combustion of methane is given by the following equation. So we have an equation here for the combustion of methane. CH4 plus 2O2 will give you CO2 plus twice of H2O, and the heat evolved in this reaction is minus 890.3 kilojoule. So how many grams of methane would be required to produce 445.15 kilojoule of heat of combustion? So we have the options here in the grams: 4 gram, 8 gram, 12 gram, or 16 gram. So you have 10 seconds to solve this question, analyze it, and after that we will see the answer. Okay, so the correct answer is option B. So we have given the heat evolved for the combustion of methane, which is minus 890.3 kilojoule, and 16 gram of methane is needed, right? Because if we find out the mass here, it will be 16. The CH4 required for del H equals to 445.15 kilojoule will be, right? So we have for 16 gram of methane, the del H is minus 890.3 kilojoule. So for 445.15 kilojoule, how much methane will be needed? That will be 445.15 multiplied by 16 divided by 890.3, and it is coming out as 8 gram. So we need 8 gram of methane to produce 445.15 kilojoule of heat of combustion, right? So option B, that is 8 gram, is the correct answer. Let's move to question number 13. Equal volumes of methanoic acid and sodium hydroxide are mixed. If X is the heat of formation of water, heat evolved in neutralization is. So we have given an acid and a base, and we mix them, and the formation of heat of formation of water is given as X. We have to find out the heat evolved in the neutralization of acid and base. So options are more than X, equal to X, twice of X, or less than X. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. As the methanoic acid is a weak acid, we know that the heat of neutralization will be less than X, because X is the heat of formation of water, right? So in the in the in the in weak acid and strong base condition, the heat of neutralization will be less than X, right? So option D will be the correct answer. Moving to question number 14. So when 1 mole of oxalic acid is treated with excess of NaOH, right, in dilute aqueous solution, 106 kilojoule of heat is liberated. The enthalpy of ionization of the acid is. So we have to find out the ionization of acid, which is oxalic acid. Options are 4.3 kilojoule per mole, minus 4.3 kilojoule per mole, minus 8.6 kilojoule per mole, or 8.6 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. So here is the equation. We have oxalic acid and it will be undergoing the ionization condition, and it is giving 2H positive and C2O4 2 negative, right? So enthalpy of ionization is given as X kilojoule. So the H plus OH minus will forming H2O, and the enthalpy for this reaction is minus 57.3 kilojoule. Okay, so and this is constant. We have studied about this is constant, that the heat of formation for H2 is minus 57.3 kilojoule, but here we have two ions of H positive, so we multiply by 2. This reaction we multiply by 2, so the enthalpy will also be multiplied by 2. So H2C2O4 plus 2OH minus will give you 2H2O plus C2O4, and this is the reaction of acid and base. Basically for NaOH we have taken the OH minus, and it will form H2O and C2O4 minus, or if we take NaOH, it will form C2O4Na, right? And the enthalpy for this reaction, it will be X minus 114.6 kilojoule. Okay, so 114.6 kilojoule is this, minus 57.3 multiplied by 2. Okay, so the enthalpy of this reaction will be this, and also we have the enthalpy of ionization is given minus 106 kilojoule, which is the heat which is liberated. But we know that X minus 114.6 is equals to minus 106, right? Because we are talking about the oxalic acid treated with excess of NaOH, and the heat liberated is 106 kilojoule in this case. And in this reaction also, we are reacting the NaOH, that is base, with acid, forming H2, and the enthalpy for this reaction is observed as X minus 114.6 kilojoule. So basically, X minus 114.6 is equals to minus 106. Okay, and by solving this equation, we have X equals to 8.6 kilojoule per mole. Okay, hence option D, that is 8.6 kilojoule per mole, is the correct answer for this question. Okay, thank you.